Welcome back. So in this example, we will be evaluating the curvature of a circle. First, it should be intuitively clear that the curvature of a circle at any point should be the same. So let's say I have a circle of radius rho. It doesn't matter where the origin, where the center is. So let's pick the center to be at the origin. And so to come up with the curvature of the circle at any point on the circle, we first parameterize the circle. So recall that we can parameterize the circle by using this following vector function. R of t is equal to rho cosine t comma rho sine t. So this is a vector function that parameterizes the circle of radius rho. So now we compute the curvature. To do so, I'm going to first compute the unit tangent vector capital T of t. So capital T of t, remember, is a unit vector in the direction of the velocity vector r prime of t. So it is r prime of t divided by the length of r prime of t. All right. So what is r prime of t? Well, this is r of t. So r prime of t would be negative rho sine t and rho cosine t. So we get r prime of t right here. And the length of r prime of t would be square of this plus the square of this, and then we take the square root. So we get square root of rho squared sine squared t plus rho squared cosine squared of t. And then we see that the length would be, if I factor out the rho squared here, then I get rho squared times cosine squared of t plus sine squared of t. And by from trigonometry or by the Pythagoras theorem, we know that this is 1. So we see that the length of r prime of t is exactly rho. So the length of r prime of t we get to so the length of r prime of t is equal to rho. So what is the unit tangent vector capital T? Well, it is r prime of t over the length of r prime of t. So notice that this is r prime of t right here, and then we divide that by the length of r prime of t. So we divide r prime of t by rho, and if we do that, we get negative sine t comma cosine t. So this is capital T of t. Good. So we now have the unit tangent vector. Now we have to find its derivative. So the derivative of capital T, t prime of t, is well, the derivative here would be negative cosine t and negative sine t here. So this is capital T prime of t. And now we are ready to calculate the curvature. The curvature of the circle, kappa of t, would be the length of t prime of t divided by the length of r prime of t. Now recall that the length of the r prime of t was rho, and if you calculate the length of t prime of t, notice that the length of t prime of t would be the root of cosine squared plus sine squared, which is 1. So the length of t prime of t is in fact 1 here, so we get 1 over rho. So we see that the curvature of a circle of radius rho is equal to rho at any point on the circle. That is, it is 1 over the radius. So this tells you that the bigger the circle is, the smaller the curvature is, right? Because it is so this is what we get, that the curvature of a circle is equal to 1 over the radius. Okay, so I'll stop the video here, and I will see you in the next video.